A resistor is a fundamental component in electrical circuits, and its primary function is to limit the flow of electric current. To understand how a resistor works, we need to delve into several key concepts from both physics and electrical engineering. 1. Basic definition and functionality. A resistor is a passive electrical component that provides resistance to the flow of electric current. It is characterized by its resistance value, measured in ohms, ohmega. The primary role of a resistor is to control the amount of current that can flow through a circuit, thereby protecting sensitive components, dividing voltages, and dissipating energy in the form of heat. 2. Ohm's law. The relationship between voltage, V, current, I, and resistance, R, is described by Ohm's law, which states V equals I times R. V is the voltage across the resistor, in volts. I is the current flowing through the resistor, in amperes. R is the resistance of the resistor, in ohms.
This equation shows that for a given resistance, the current flowing through the resistor is directly proportional to the voltage across it. If the voltage increases, the current will also increase, provided the resistance remains constant. Material properties. Resistors are made from materials that have a specific resistivity, which is a measure of how strongly a material opposes the flow of electric current. Common materials used for resistors include carbon, metal films, and wire-wound materials. The resistivity of a material is influenced by factors such as temperature, which can affect the resistance of the resistor. 4. Energy dissipation. When current flows through a resistor, electrical energy is converted into thermal energy due to collisions between the charge carriers, usually electrons, and the atoms in the resistor material. This phenomenon is described by Joule's law, which states that the power P dissipated by a resistor is given by P equals I times R, or equivalently, P equals frac V to R. P is the power dissipated, in watts. I is the current through the resistor, in amperes. V is the voltage across the resistor, in volts. R is the resistance, in ohms. This power dissipation manifests as heat, which is why resistors can become warm during operation. 5. Types of resistors. There are various types of resistors, each designed for specific applications. Fixed resistors. These have a constant resistance value and are the most common type. Variable resistors, potentiometers. These allow the resistance to be adjusted manually. Thermistors. These resistors change their resistance with temperature. Photoresistors. These change resistance based on light intensity. 6. Resistor in circuits. In a circuit, resistors can be arranged in series or parallel configurations. Series resistors. The total resistance is the sum of the individual resistances. The same current flows through each resistor, but the voltage across each can vary. R total equals R1 plus R2 plus R3. Parallel resistors. The total resistance is found using the reciprocal formula. The voltage across each resistor is the same, but the current can vary. Frac 1 R total R1 R2, frac 1 R3. 7. Applications of resistors. Resistors are used in a wide range of 7. Applications of resistors. Resistors are used in a wide range of applications, including current limiting, protecting components from excessive current. Voltage division, creating specific voltage levels in circuits. Signal conditioning, adjusting signal levels in analog circuits. Biasing, setting the operating point of transistors in amplifiers.
Conclusion. In summary, a resistor works by providing a controlled opposition to the flow of electric current, converting electrical energy into heat, and playing a crucial role in the functionality of electronic circuits.